You were present. You were present in the last class. You was there. I think there was one more girl. Is coming on the way.
She might be
late. Then I think everybody will late. Okay. Wait. Brakes. Okay. Brakes. Right. So which means hydraulic machines, right? Yes. So the three hydraulic machines that we covered was
hydraulic jack, hydraulic.
that's hydraulic brakes, right? So any doubts in this? Do you remember what was the principle on this table? Which principle these machines worked on? Pascal's law, right?
Yeah.
We have worked on Pascal's law. Anybody remembers what is Pascal's law? Pascal's law. Pascal's law is whenever what? Whenever pressure is applied to a confined liquid, right? That applied pressure is transmitted equally to all parts or at every point. Yes. Yes. The transmission is equivalent until it's at every part in the liquid, right? Pressure, blood pressure. So, confined liquid is, yes, it's transmitted. So this is like revision of what we did in the last class. Applied pressure to a confined liquid is transmitted equally and undiminished at all points in the liquid. So this you need not write. I think you've already done this. So anybody has any doubts so far? Okay, so let's go ahead. So what is the next topic? Atmospheric pressure. So, if anybody has any idea what is atmospheric pressure?
Pressure applied by the atmosphere. Yeah.
Yes, pressure by the atmosphere. So,
Very colorful air.
correct. So, if this is Earth, right? So, Earth is surrounded by envelope of gases, right? Which constitutes atmosphere. Earth is surrounded by the envelope of gases, which is called atmosphere. Right? So, if somebody stands here, right? So, he is actually standing under the air column, isn't it? Okay, and this air column extends right up to 300 to 400 kilometers. Yes. Got it? So, atmosphere extends up to 300 to 400 kilometers above Earth's surface. So, this air column will have its weight, right? Here is fluid. So 300 kilometers of air column will apply some stress. What do you call? Thrust. So this thrust will be due to weight of air column. Isn't it? Right? So like if I am standing on this floor, I am exerting thrust on the floor. Right? Straight. My weight is exerting thrust on the floor. What is thrust? The perpendicular force. Right? So weight always causes thrust. It always applies perpendicular force because it is towards the center. Right? So what is atmospheric pressure then? The atmospheric pressure is what it should be? Thrust upon unit area. So whatever is the thrust acting on unit surface area, right? So thrust upon area, isn't it? Did we define pressure like this? Thrust upon area. So thrust due to air column per unit area. Air column per unit area. Okay, that is atmospheric pressure. Is it understood by everybody? Atmospheric pressure is what is that? Everyone has signed it? All of this signed, right? So thrust due to air column per unit area. That is atmospheric pressure. Right? And 1 atm is given as the unit in which atmospheric pressure is measured is atm. It is equal to 1.013 into 10⁵ Pascal. Okay. So at sea level, which is at sea level. Can anybody visualize how big is this pressure? So Pascal is basically what? What is Pascal? Which is Newton per meter square, right? Force upon area. So if this is almost equal to 1, that means if this person is experiencing an atmospheric pressure of 1 atm, that means 1 lakh Newton of force is experiencing 1 lakh Newton of force upon himself. What is the surface area of human being? 2 square meter. Roughly 1 meter ahead, 1 meter behind. So our surface area is roughly 2 meters square, right? So this is like how much? 1 lakh divided by 2. 2, which is how much? Almost 50,000 Newton. Meaning there is a 50,000 Newton kept on us. And what is 1 Newton? Yes, 100 gram, right? So 10 Newton is caused by 1 kg of force. If we divide this by 10, so how much is this? 5,000 kg. Like we are under 5 tons of weight of mass. So why are we not crushed?
Because our blood is exerting.
Because of what?
Blood is exerting.
Yeah, it is due to the blood pressure. So who is responsible for the blood pressure? The heart. Can you imagine how strong is heart? Right? So if heart was not pumping, right? So we will not be able to survive. Okay? Is it giving you some kind of clue like how much heart is capable of? So if one is dead, then why is not crushed? If one is dead,
What is
See, like we are right now alive, so heart is pumping. What when we are dead? Are we squeezed? We don't know yet, right? So if you have seen dead body, right? It is not squeezed, right? So the way we can explain that is a dead body will have an open mouth. Even if we keep open mouth, right? Yes. If the mouth is open, right? Air seeps inside. So its pressure is maintained, right? So if we keep the mouth open, it's maintained. Okay. So what I was trying to say is if the mouth is closed and if the heart is pumping, you're still able to. Anyway, this was just to give you some sense of the ability of the heart, right? But this is what you have to understand. What is atmospheric pressure? Is it clear? Okay. So next topic is how to measure it. Atmospheric pressure. Having understood what is atmospheric pressure, let us now learn about measurement of atmospheric pressure. Just go out and sign. So everybody is now familiar with the definition of what is atmospheric pressure, right? So it's simple. It's just the definition of pressure thrust upon area. But here the thrust is due to air column. That's not the difference. So anybody remembers the formula of pressure from last class for a fluid column or a water column?
height, rho, acceleration?
Yes, H rho G, right? So pressure formula we derived in the last class was H rho G, where H was the height of the liquid. So here it is the height of the air, right? So we'll make use of this formula for measuring atmospheric pressure, right? So we have to be able to do it in lab, right? We won't be traveling to measure height, what length of atmosphere it is. Okay. So we make use of mercury level. To measure atmospheric pressure, we will use mercury column. Mercury symbol is H column. Okay. To measure atmospheric pressure. So what is the process? We'll take a tube, glass tube, 1 meter long. Okay, so glass tube roughly 1 meter long. Or 1 meter height. Right? And we will fill it completely with mercury. This will be filled with mercury. So this is filled with mercury. Till its brim. Okay, it is totally filled. Now what we'll do is we'll take a trough. Okay, and this is also filled with mercury. In the trough also you have mercury. With mercury. This tube, which is filled with mercury, will now be inverted into, right? So we close it with the thumb. So we place our thumb here, right? So it is closed with our thumb. And now we will invert it into this trough, something like this. So this mercury which was filled, right, it will start spilling into the trough. Okay. But we will see that after reaching a certain height, I mean, after dropping with certain height or depth, okay, we will see that now it is not emptying, it will stop at some place, right? So when this was measured from the level of free surface in the trough to where it stopped, this height is coming to be 76 centimeter. Okay, so are you with me? Which is nothing but 760 millimeter, right? So how do we explain this? How do we explain this? We can explain it like this. When water flows through the pipe, suppose you have two cylinders. Let's say little tap arrangement over here. So here the water is full at this level, and here the water level is this much. Okay. Now when you open the tap, what will happen? Water will flow in this direction. Right? Till when this will flow? When level in both the cylinder is same. Okay? Liquid seeks its own level. Right? Then what happens? Will it still flow? Once the levels are same? No. So why was it flowing when the levels were different? Because it's a fluid. So what is the height here? The same liquid. This is H2. Here it is H1. Right? So what is P1 at this side? At both ends. What is P1? H1 rho water mg. What is P2 at this side? H2 rho water. Rho means density of water. Both sides are same. But H1 is greater than H2. Right? So H1 is greater than H2. What does this mean? P1 is greater than P2. So liquid flows till pressure at the left. This side has to be more than pressure on the right. Understood? Liquid flows due to pressure difference. It will always flow from higher pressure to lower pressure. If the pressures are same, then it will stop flowing. Is it clear? So what is the condition for flow? The pressure should be higher, okay, at one point than the other. So initially, when this column was full, when the test tube was full, so pressure at this point, let's call this point as A. Okay, and pressure at this point, let's call this point as B. So pressure at A was greater than pressure at B. So this liquid was flowing. Okay, but when this height reaches here, okay, like it dropped by this much amount, then now it is not flowing. Now it is not flowing. So what is the explanation? Now the pressure at A is equal to pressure at B. Got it? Pressure at A must be equal to pressure at B. That is why the liquid is not flowing. But what is the pressure at B? Atmospheric pressure. Pressure at B is atmospheric pressure. Therefore, now pressure at A also should be equal to atmospheric pressure. But this pressure is equal to pressure due to this height of this liquid. Got it? So what is the pressure due to the height of the liquid? So pressure at A is equal to height of the mercury column, density of mercury, okay, into G. Got it? So therefore, PE, what is B? It is P0. I told you the atmospheric pressure is P. Therefore, P0 is equal to PA, equal to H1. Got it? So now we'll calculate. We know what is the density of mercury. What is density of mercury? Height was 76 centimeters, which is 0.76 meter. 0.76 meter into what is density of mercury? 13.6 into 10 raised to 3. What is acceleration due to gravity? 9.8. Okay. So when you solve this, you will get 1.013 into 10 raised to 5 Newton per meter square or mass. So this is what is your atmospheric pressure. So what I just gave you this value, get this value like this, experiment it. Okay, so this is only for explanation. This is not part of it. This was to explain you that when pressure becomes same, there will be no flow. So pressure at one end of the pipe has to be greater for the flow to take place. So here when pressure at A and B becomes equal, that's when the flow will stop. Okay. So which means the pressure outside must be equal to the pressure due to this liquid column. That's why now this liquid column is not further dropping. So the atmospheric pressure outside is holding this column. So they are balanced. Is that clear? ठीक है, किसी को नहीं समझा तो पूछ सकता है. So take few minutes to absorb this. Lastly, if you have any questions.
So which is the densest fluid?
Mercury. Yes. Can you erase this right side?
So why specifically 76 centimeters?
Sorry.
Why specifically 76 centimeters height?
So this is what is observed. This is experimentally observed. It is experimental fact.
Why not? And then increase rate?
So you use a liquid of lower density, you get an increased height. But again, with that also you will get same answer. Let's say if you use water instead of mercury, right? What is the density of water? It's 1000. 10 raised to 3 kg per meter cube. Okay. You have to remember density of water because it's a simple figure to remember, right? Mercury and water, these are like you'll come across these numbers often.
So, but like if we increase the height, having the liquid work here, but increase the height, would the answer change?
Of course, when you increase the height, first of all, you can't increase the height because when you increase the height, the pressure inside the tube will become more than the atmospheric pressure. So it won't stay. Once you invert the tube, that height will always you'll find 76. It's like acceleration due to gravity. It's 9.8. Some other place it will be more or less, depending upon how far the distance is from the center of the earth. So this is fact, right? At sea level. But if you go on top of the mountain, what should happen?
The atmospheric pressure increase.
Yes. Why?
Because this column of air.
Yes. Because of the height of air column reduces. The height of hill is subtracted from the height of the air bubble. So height reduces, so pressure reduces. So it's very simple, right? Once you will catch the concept, you will not forget it. So everybody has the textbook.
Yeah.
Now that you have understood atmospheric pressure, there are certain demonstration of atmospheric pressure, right? So the first one is collapsing tin can experiment. So what is this experiment? Suppose you have a tin can, right? And you have a water inside. Yeah. So it was like filled 1/4. Okay. So what is inside the tin can when the can is filled? Yeah, what's the issue? उस पे आते हैं, so don't worry, I will discuss that. So first pay attention here. So in this, how much the liquid is filled? 1/4 roughly, or 1/3, right? What about the empty space? It is full of
FT.
air, not hot. So initially it is a cold water and this space is air, right? Now what we are doing, we start heating. So when we heat it, this empty space which was earlier full with air will now be filled with steam. So there is no air now. The air is pushed out. What you have is steam.
But wouldn't the steam be pushed out because it has less gas?
So it is occupying. So it will take place in stages, right? It is anyway going up. Okay. But when, so imagine that situation that there is still water. As long as there is water, there will be steam. So earlier the space was occupied by air. Now it is filled with steam. No air. So in that situation, now what you do is you now cap it. Close the lid. Okay. So now what has happened? After you place the cap, wait for it to cool down. Is there air inside now? No. So you're not even waiting for cooling it down. You now sprinkle water from outside. So the steam inside will become cold or condensed. So once it is condensed, it will again get converted into water. So now there is no air inside to hold the atmospheric pressure. Earlier, when there was air inside and outside, so the impact of atmospheric pressure was not seen on the water. Now, once the inside thing condenses, there is no air inside. So outside pressure is more. This bottle will be disfigured. Okay, so it will not be able to handle the pressure due to atmosphere outside. It will be disfigured. Understood? Okay. Then say
So this wouldn't happen in vacuum.
this can happen in vacuum if the container is not strong enough to hold the atmosphere.
But then there's no atmosphere in vacuum.
So there is no atmosphere. So the container has to be really strong. So the vacuum containers are very thick metal sheet. Hold the atmospheric pressure. You should have the strength, right?
But in vacuum, there's no atmospheric pressure.
Nee, but the strength is there to hold the atmospheric pressure. How are we able to send rockets in space? Rocket doesn't get crushed. So there is strength of material. So you have to have material which can withstand that pressure. We as a human can't, but you can have other things.
But what is the pressure acting on it?
Let the pressure act, but the bond inside solid is so strong that it can withstand that pressure. We are not that strong like iron.
I didn't understand what's the pressure acting on it in vacuum.
Whatever is the pressure, it is atmospheric pressure outside.
But then
Like
there's no
you have
pressure.
this carriages. They take tons and tons of goods, right? The railways. So they are made up of metal. So there are different substances which are different holding together. So let we as a human can't, and this is the thin tin, right? If it is a glass, you can have a steel container, even that will not be crushed. You need a material which can hold that kind of a weight. You're not convinced.
No.
What is your
My
what is
question
the
was, for example, this is a vacuum.
uh,
And in that vacuum, you put the container.
in a vacuum you put a container.
Yeah, with the same experiment.
In a vacuum you put a container.
Yes.
Okay.
In the
Then
vacuum, put the container and you evaporate the air is no longer in the vacuum, it's taken out of the vacuum. But like when the steam condenses
So
to
when
water,
it is a vacuum, right? So now you are putting a container, and air will fill in. No, it has to be isolated in one. Vacuum is no air, but when you no, but how do you put the container inside?
okay.
Okay, so what you can do instead is you have a bigger container. Inside that you put a smaller container and suck the air out.
Right. Basically, it converts steam converts into water.
So
It's in vacuum.
can we? I mean, we are getting into hypothetical direction. Can we just take it offline? Because we have only 1 hour. So this can be a very lengthy discussion.
Right. It's just,
So what? So quickly within 5 minutes. Yeah, what
Right.
is it?
So basically, if this is put into vacuum, then there's no pressure acting on it, but it's still like,
Like, what is your question? You frame your question. Now.
right. So
You
But
put
it's
it
still
in
contract.
vacuum. I understood. Then
Yeah.
what is the question?
my question is, would it still contract?
No. Why is it contract?
Yeah, because you were saying that I said it.
I said-
it's in contract.
You see, it is contracting because outside your atmospheric pressure into air,
So in vacuum.
but inside it is vacuum. So there's nothing to hold that pressure outside. In our body, it is hard. There has to be somebody to hold that pressure, outside pressure. Now, what is there in this vessel?
Yeah.
Nothing. That's why. But if it is vacuum, there is anyway nothing. Okay. So that does that answer? I still have not got the logic of your question.
Yeah, my basic logic was, what if there's not atmospheric pressure, it's vacuum, then would it still contract? That was my question.
No. See, if it was human in the space, then we'll just explode
Right.
because of the heart. The outside pressure, there is no pressure outside to bend. Like if you climb the hill, then your nose will begin to bleed. Because the inside pressure becomes more than outside pressure. Okay? So are you listening, everybody? When you climb hill, your nose will begin to bleed. Because now outside pressure is less than your internal pressure, internal blood pressure. Blood will ooze out. Huh? Yes. Maybe the eyes and ears also. You never know. So that is why when you go to higher altitude, you go through exercise called acclimatization. Okay, so for 2-3 days you will be put up in a base camp till your body becomes used to that low pressure. Not only that, you'll have to breathe heavily. So you'll have to like sniff, like your lungs have to really work hard. Here, the atmospheric pressure outside is helping. With natural breathing, they are able to do. But people who are living at low-lying areas, when they go to hilly areas, they will have problem breathing also. Okay, so within 2-3 days, you can you can get used to it, right? So can I go to the next example? Now, how do you suck water using a straw? Huh? Listen. Okay, first everybody listen. So in the straw, right, the portion of straw upper than water has air. So when you suck it, what you do is you suck the air from the straw. So once the air from the straw is sucked in, now the atmospheric pressure outside. So the pressure in the straw is less now. This will start rising because this pressure is more than pressure inside the straw. Got it? So what we have done is we have emptied the straw with the air inside. And then this atmospheric pressure will push. And once the flow begins, then it is very easy. So once the flow begins, then it is easy. Then the effort is not more. Initially it may be more, but then it goes easily. Okay? Because the atmospheric pressure continuously pushes the straw. Understood? Same here. So when you try to pull the injection in the syringe, so what do? You first completely remove the air inside the syringe. Have you seen it? Have you all taken vaccine shots?
Yes.
So, no. Actually, last time also we discussed this. So the syringe is completely emptied. Okay. Then the injection is pulled down. So when you put, there is no air anyways. Okay, so inside pressure will be less. Then the atmospheric pressure will help the stuff get filled inside the syringe. Is that clear? Okay. So this is all the consequence of atmospheric. So filling of ink into a fountain pen, again like that. So all these sucking actions, the sucker, it's not a, so action of a rubber sucker. What is a rubber sucker? So have you used it in your house?
Yes.
The silicone hanger.
Yes.
So what you do is, it's like a cup. Okay, so when you place it on a plain wall and then press it, so the air inside is removed. So now there is no air in this between the wall and the cup because you completely pressed it. Then when it tries to come back, now there is a vacuum created. So there is no air between the wall and this sucker. And the atmospheric pressure from outside presses it to remain stuck with the wall. Is it understood? Okay, so this is how this thing works. Why you guys are so serious? Just a sucker. Okay. Okay. Now this is a Cyphon Action, right? Getting wild ideas it seems. Now this is a liquid or some fluid kept at a higher level than at the lower level. Okay. Now you are using a pipe to pull this liquid from the higher level at lower level. Now see, if there was a hole here, the liquid would naturally flow, right? But here what is happening, it is going up and then going down, right? So now imagine when this thing was kept here, you must have seen people sucking petrol and putting into different vehicles. Have you seen it in movies? Yes. Yeah. So what happens is, it goes up the tank and then come down. So, but initially when you put the pipe, it was all empty in this portion. Whatever is not immersed in the fluid, outside is air. Okay. So again, you suck the air out, and then what happens? This atmospheric pressure will help fill this tube. As long as the air is emptied, the fluid is filled now. So now this atmospheric pressure is pushing it so that it is pumped down. So this is called Cyphon Action. What is it called? Cyphon Action. So this is also a useful consequence of atmospheric pressure. Right? So the same thing is used in taking out oil from the seed can. In villages and all you will see, but now we have pumps also. So you don't have to spoil your mouth. Okay. Sometimes when it's stuck, it goes inside also. Right? So start coughing and it is not good for that. All right. You have seen that, right?
Yes, that also. पेट्रोल निकालेगा अच्छा एक बार खत्म हो गया था
अंदर नहीं गया था ना पेट में
नहीं पूरा पूरा कुछ नहीं पड़ता इधर आने तक तो छोड़ देगा
वही तो जब तक पाइप में एयर है एयर निकाल दे तो बाकी का काम एटमॉस्फेरिक प्रेशर
स्टार्टिंग में पूरा खाली रहता है एक वो लेवल के ऊपर रहेगा तो ऊपर नहीं आएगा नीचे आना चाहिए और फिर इधर तक आया तो फिर छोड़ देगा फिर बाकी का
क्योंकि वो ग्रेविटी का एक्शन और एटमॉस्फेरिक एक्शन दोनों एक साथ आ जाता है दैट इज कॉल्ड सिफॉन एक्शन दिस गर्ल इज लाफिंग व्हाट हैव यू फाउंड नथिंग So next time when you are put up in that situation, Cyphon, will you be? Arey, it's okay. I'm just saying you understood Cyphon action, right?
So he's supposed to appear.
You need what?
Supposed to appear.
Yeah, you are sucking it, right? So then it will come out. Yeah, so it has to be a good balance. If you suck it so hard, then it might enter your stomach. Now that will be lethal. If you gulp good amount of it. 2-3 gulps will be harmful. Okay, maybe vomiting and all will say. All right. So I think you have got it. Measurement of atmospheric pressure. I already discussed it. Okay. So what we discussed is Torricelli's barometer. Right? Who did this experiment first? Torricelli. So some Italian Torricelli's barometer. So this instrument is called barometer, right? So what is the fluid used? Mercury, right? So then there are advantages of using mercury, right? Advantages. What are the advantages? One is it doesn't stick to the so you can read through these points.
It is okay.
It is opaque, yeah. So all 2-3 advantages, more advantages. Just read through it.
Opaque doesn't matter that much, right? Even if it's what doesn't matter.
Opaque is something which doesn't allow light to pass away.
Right.
Okay.
So I said that.
Like mirror. Mirror is also opaque. So you can see yourself in the mirror because it is opaque. It reflects the light back. If the light passes through it, then you will see the other side. You won't see yourself. So that is why, because it is opaque, it is clearly visible. Second, it does not touch the, it doesn't stick to the surface of the glass. Okay. So it is easy to see the level of the mercury, right? And these are the things. Also, in this area, some of the mercury level dips. Okay, so what is there in this area? What is here? Huh? Mercury vapor. Yeah, it's mercury vapor, and that pressure is almost negligible. Okay, so it's almost like a vacuum. Okay, what if you would have used water here? Then it will be water vapor. It will have water vapor, and water vapor pressure is more than mercury level. So if the pressure is more, it will push this level down. So it will not show, this height will not show the actual atmospheric pressure. But it will show incorrect reading in that case. Okay, so when you read this advantages and disadvantages of mercury as a parametric liquid, then you'll appreciate why we are using it. Okay, so all the advantages of mercury become disadvantage in case of water. It is not clearly visible because it is transparent. It sticks to the surface. Okay, plus the vapor pressure, water vapor pressure is high. So the height of water also is not correct. Okay, we're getting less reading. Got it? So these 2-3 advantages, disadvantages, differences you remember. Got it?
Uday sir,
Yes.
good evening sir. Can I take 1 minute?
Yeah, go ahead.
Yeah.
1 second, your volume is pretty low.
I-
How do I increase the volume? So yes, scale. Where is volume? Madam, boliye.
Actually, this is for students. This is regarding doubt solving. Just listen here. Every month we are conducting doubt solving, but I don't know how many of you have attended our monthly doubt solving. This time you are not getting this monthly doubt solving link on your WhatsApp group. Okay, it is there on our website. Go to our website, and by using your login ID and password, you can click it on extra links. There you are getting our monthly doubt solving sign up link, and click it. Which subject is you are required, like that you can go through with the sign up links. But how to go? Go to website www.universaltutorials.com by using your login ID password. Henceforth, please follow this step, not on WhatsApp. Is it clear?
Yes.
Yeah.
Okay.
Thank you, sir. Thank you. Yeah.
Okay, so what he said is, you used to get WhatsApp message now for doubt solving. Those alerts will not be sent now anymore on WhatsApp. So anybody who want to book a doubt solving session, you have to sign up on Sign Up Genius, right? You go to Universal Tutorial site. There is a link to Sign Up Genius. Ultimately, it will be managed on Sign Up Genius only. Got it? The link will not come on WhatsApp now. Link will be on the UT website. Okay. So now it will be voluntary. You have to make an effort. Now no more alerts. Okay. Because these were messages were going, but nobody was coming. That's that. But many students were coming also. Haven't seen anybody from your batch. You attended for physics or for maths? For maths. I have not seen anybody from this batch for physics. Did you attend? Was with me? Then Yogita. Yogita madam ke saath kiya hoga. So just take benefit of this. Achha, one more thing. We said this height is 760 millimeter or 76 centimeter, right? Now if you tilt it, okay, like here. So this height from the free surface of the Mercury and this height, the vertical height remains same. It is not going to change. Understood? Okay. The length in the tube will increase if you slant it, if you incline it, but still the top Mercury level with the free surface of the top that remains 760. The vertical height always remains. Is that clear? Okay. So it is because of the atmospheric pressure does not change, right? If you tilt the Mercury or do whatever, so the height is maintained. Okay. There are two more types of instruments to measure atmospheric pressure. One is 14 barometer and the aneroid barometer. So that is not in the course. Okay. Only Torricelli's barometer that will be discussed here. Now, one small point, variation of atmospheric pressure with altitude. We'll discuss that now. So, is the advantages and disadvantages clear? So, advantages of Mercury and disadvantages of
Water.
the other liquid is water, is it?
Yes.
Oh, water. Right. So here the height was 760. What was the height in case of water? Any idea?
10.4 meters.
It will be almost 10.4. Now imagine if you are conducting the experiment in laboratory and you have to hold a 10-meter long test tube. Any idea how many meter is this height? 3 meters. Around 3 meters. So 2 floors and a half test tube.
A test tube there.
Will it be convenient? No. That's why it is advantage.
Why not something like oil?
Yeah, so density should be there now. Oil density still will be less than mercury. It may be little more than water. Still, it will be like, let's say, so 10 meter give me now 6 meters. Still, that's not good.
What's the reason?
Yeah. So because mercury is the most dense. Okay, understood now? Okay. Last is variation of pressure with height. Pressure or atmospheric pressure? What is it? Atmospheric pressure. This entire chapter is dedicated to atmospheric pressure. So we have already discussed it. With height. Now what should happen with height? See, P is equal to H rho G. So as height increases, two things happen. Listen, this is about atmospheric pressure. So this is Earth, okay? So Earth, what you have is, imagine the air column at this surface. So one is the height aspect of it. Second is density of it. Density of air is quite high as close to the surface of Earth. All the air molecules are packed close, right? But as you go up, the density is quite sparse. Density of the air is less. Okay. So when the height increases from the surface of the Earth, initially the density reduces very fast. Got it? So there is no linear decrease. The density reduces faster at closer heights to the surface of Earth. Right? Density decreases, rho decreases faster at close to surface of Earth. Faster with height. With height. Close to Earth's surface. Is it clear? But at greater heights, the decrease in density is very, very less. because anyway it was less dense. Okay, so the difference is not much. So when you plot a graph of height versus atmospheric pressure, right? So what happens is, this is it height or density? Density. Is it height or density? What is the graph?
Height.
Height here over.
And
Yes. So height is here. This is height. Okay, and this is atmospheric pressure. This height is basically from sea level. Okay. So when this is 0, that time it is, what is the atmospheric pressure? 76 mm of Hg column, right? So that's why you have what? What is the value mentioned here? 75 or 76, right?
70.
So this is in centimeter of Hg. So when the height was 0, this was so 75 here, maybe 25, but it is somewhere here. So, but then it decreases drastically. So initially, so with every 6 kilometer, 6, 12, 18, 24, right? Now see, so from 0 to 6, it decreases drastically. Then 6 to 12, it doesn't decrease that drastically. 12 to 18, the decrease is even further. Can you see what was the decrease here from 6 to 12? This much, dropped this much. Now between from 0 to 6, it dropped this much, right? So delta P was very big, very high over here. But in this case, now it is reduced. From 12 to 18, it is reduced up even less. Okay. So the drop in the pressure with height is reducing. It's not significant. So now you understand how to read this graph. Okay. So the decrease in pressure is not linear. Whenever the graph is not a straight line, we say the decrease is non-linear. Why? Because the density does not decrease linearly. Okay. So, and I'm sure motion wale chapter mein you must have studied about different graphs. So you have an idea about what kind of graph is this. This is a non-linear graph. So variation is not in direct proportion. This is what it is, right? All right. So we have time till 7:30. 5 more minutes. So any questions here? This is clear. Now the last is it can be used as weather forecasting and altimeter. What is altimeter? Yes. So you know that at higher altitudes the pressure decreases. So we can then calibrate it in terms of height instead of pressure. Right? We know at what height what pressure is there. So corresponding to the pressure, one side we will mention height and the other side we can mention pressure. So experimentally, it is just a calibration exercise. So you take the barometer, go up, right? Corresponding to pressure, the height is already mentioned. So that is how an altimeter works. So it's called altimeter. Okay. The same barometer can also be used for weather forecasting. So what is weather forecasting? Weather forecasting. कैसे use करोगे इसको? Altimeter, everybody is understood, right? Altimeter means altitude meter. Altitude meter. So the pressure is now calibrated in terms of height because we know this formula. X rho G. Rho and G is constant, therefore pressure is directly proportional to height. Okay, so whatever is the pressure value, accordingly you will have heights. Okay. Now, weather forecasting mein, suppose in this, right? So ideally it should be at sea level, it should show 76 centimeter. Okay? This is the normal atmospheric pressure. Now we find a sudden fall. When the level falls suddenly, meaning what? The height is reduced, meaning what? Pressure is reduced. So low pressure, sudden low pressure means what? Cyclone. Okay? When there is sudden fall, that means the air has moved. So no pressure, no atmosphere. Right? So sudden fall means cyclone. You can expect a cyclone. Okay? So when there is a slow fall in the level, that means what is happening? The air is slowly reducing. So the air density is reducing. So that means what? Air is becoming humid. The moisture is increasing. So air is replaced by moisture. So you can expect a rainfall. The slow fall will, you can expect rainfall. Okay. Now, what if the level is rising? Rising.
It is sunny.
Yes, the air is coming, so that means it is dry. So rise means dry weather. Okay, rise of level is dry weather. Sudden rise, extremely dry weather, right? Do we have sudden rise? It will be extremely, and no rise means fair weather. So sudden rise in the barometric height means extremely dry weather. Okay, understood?
Yes.
So sudden rise because air is increasing outside. So that means extremely dry. Weather. And not much change. There is no abrupt change in fair weather. Okay. So it's all about from the level you can sense. Okay. What is it? No abrupt change. So this is how you can figure out the weather. Means fair weather. So with this, we are through with pressure in fluids and atmospheric pressure chapter. In the next class, I think we'll take numericals. We have had 3 classes, right, so far. No. Last class was 2 lectures. This is 3rd lecture. 1 more lecture, right? So 1 more class. In that, we'll do numericals. So I think concept-wise, are you all clear now? What is pressure and how to figure out the height, pressure, density, advantages, disadvantages, weight, vacuum. Okay. So this is it. We still have a minute. Anybody has doubt can ask. So how do you like the pace of the lecture? Is it too fast, too slow? Just okay. Huh? Proper. Very good. So feel free to ask. I will change this time. So I may not follow sequence, but I feel the sequence will be better for understanding. So I take that way. I may not follow the book sequence for the same chapter. But this way I think you will grasp better. Okay. So in the next class, whatever I have covered so far, read, try to attempt questions yourself, right? We'll discuss those questions. If there is any concept there, that also will be clear. Will you press the bell or is it okay? It's time, right?
Yeah.
Sure. I'll see you next.